All right, so we're multiplying together this factored polynomial into standard polynomial form. I'm going to start generally by trying to take care of the conjugate pairs of complex numbers first, just to get rid of any complex numbers in the scenario. So in this one, we have x plus 6i, x minus 6i. Most students I've taught generally prefer the box method for multiplying polynomials. So I'll demonstrate that one out right here. And all you're doing is writing a row and a column with your two polynomials, and you're just going to multiply each term. All this is a shortcut for the distributive property, and you get the same result doing different methods. So x times x gives us x squared. X times negative 6i is negative 6ix. 6i times x is 6ix. And 6i times negative 6i, 6 times negative 6 is negative 36. And I times I is negative 1. And negative times negative gives us positive. So negative 36 times negative 1 made this positive 36. And we combine our like terms here. We have 6ix minus 6ix, which is just 0. So we are left with the x squared plus 36. And that is the product of x plus 6i, x minus 6i. So we have x squared plus 36 here. We can just continue to multiply these binomials. I'm going to go ahead and do these two, x plus 1 times x minus 3. I'm going to use a different one of the strategies. Many of you have heard of FOIL. Some of you have used what's called the lobster claw, I guess, or what I call the lobster claw. But all of it is just the shortcut for distributive property. We're distributing everything in this parentheses to everything in that parentheses. So I'm just going to draw an arrow from x to everything in the other parentheses, and then I'm going to draw an arrow from 1 to everything in the other parentheses. And for every arrow, I'm just going to multiply those terms. So we have x times x is x squared. We have x times negative 3, negative 3x. We have 1 times x is x, and 1 times negative 3, negative 3. And if we combine our like terms here, this simplifies to x squared minus 2x minus 3 times x squared plus 36. Now, I'm not going to finish this problem out, but I am going to kind of model out how we would do the multiplication. And you can see that you could keep going and continue multiplying the x plus 2. I'm not sure if that's a typo and the capital X has a different meaning, or if x was supposed to be multiplied with everything here. But that one's pretty trivial. Once you get the rest done, all you need to do is multiply each term by x, and you're essentially adding 1 power onto x in each of the terms. But let's go ahead and use that box method to multiply the x squared minus 2x minus 3 and the x squared plus 36. So we have x squared minus 2x minus 3 times x squared plus 36. And we're just going to draw out a box for each term and multiply rows with columns. X squared times x squared is x to the 4th. X squared times negative 2x, negative 2x cubed. X squared times negative 3, negative 3x squared. 36 times x squared is 36x squared. 36 times negative 2x is negative 72x. And 36 times negative 3 is negative 108. And we can now combine our like terms. We have 36x squared and negative 3x squared. So those are our first like terms. And in fact, only like terms here. So x to the 4th minus 2x cubed plus 36x squared minus 3x squared is 33x squared minus 72x minus 108. And this would be our polynomial x plus 1 times x minus 3, x plus 6i, x minus 6i. And you would continue by doing the same process with x plus 2 times x.